Alright, moving on. Let's look at our last couple problems on our review. As we finish up our unit, we talked about graphs. We looked at symmetry, and then we looked at transformations of graphs. So we'll look at transforming graphs using their parent models, using their basic function that they derive from. And we talk about three major properties that we went over. We went over shifting graphs horizontally and vertically, which we want to be able to recognize quickly in a function. And we talked about reflecting a graph, right, about the x to y axis. So we had horizontal shifts, vertical shifts, reflections. If you can remember those three properties, we can easily get a quick sketch of a graph, which will allow us to talk about domain, range, turning points, just knowing those key transformations. So let's take a look at this example here, which is a square root function. We're looking at square root of f of x is equal to negative square root x minus 3 plus 2. It says, how would you obtain that graph from its parent model, which is the graph of y equals square root x? So let's talk about the transformations, and then we'll use that to help us sketch it. So as I look at this function, you say, well, what's different from where it's derived from? So let's go ahead, while we're at it, I want to go ahead and begin talking about the graph of the square root model. So let's build our x and y axis. All right, as we do that, as we build in the x, y axis, the square root function. So if you're looking at the graph of the square root of x, all right, well, begins here at the point 0, 0, and it increases for all x. It's an increasing function. With that said, just to list a couple of points, we know on the graph of the square root of x, we know the square root of 1 is 1, so 1, 1 would be a point we could use. We also know, for example, we know the square root of 4 is 2, so 4, 2 would be another point on the graph of square root of x. So again, here's our parent model. Here's our parent function. So now we want to talk about f of x. So as we're going to graph it, let's explain the transformations. So the first thing I want to do is go ahead and talk about this negative. So the negative is a reflection characteristics. So with the negative, we're going to reflect the graph we just drew in, reflect the graph of y equal to square root of x. All right, across the what? X-axis. Anytime you multiply your function by negative, all right, you're going to take every ordered pair x, y, and you're going to produce x negative y, which flips it directly across the x-axis, which turns it upside down. So upside down, another word for reflection with the x-axis. So that's what the negative does, right? It causes the graph to reflect. So let's go ahead and do that, and we'll put our new graph in a different color. Let's put it in blue over here. So as we graph that, well, let's take these points that we plotted. So for example, 1, 1, as we reflect across the x-axis, be 1, negative 1, right? So as we go ahead and build in the reflection, right, here's where our graph would be. And let's put in, let's put in a dash line, because we know it's not our final result, so I'm going to dash it in. And with that said, so 4, 2, of course, if you reflect, that would be down here, 4, negative 2. But there are those reflections. So there's the sketch of y equal to negative square root of x. So that takes care of the negative. All right, as we move on in our characteristics, you say, well, what about this minus 3 in here? Well, anytime we add or subtract a constant to your domain variable, you shift your graph horizontally, left or right. If we have x minus a positive number of 3, we're going to add 3 to every x coordinate. We're going to shift the graph to the right 3 units. So we define x, we always define it with a minus sign. So you can put your hand on the minus and ask yourself what number's to the right of it. Is it a positive or a negative? If positive, we go right. Negative, we go left. So now we're going to shift our graph. Shift the graph. Right 3 units. Alright, so we're going to take every ordered pair. For example, every ordered pair xy, that's going to produce the ordered pair of x plus 3y. So just like the reflection about the x-axis, every ordered pair xy produced x negative y. So let's go ahead and do that. So we're going to add 3 to every x-coordinate. So let's go ahead and transform. So this starting point is 0, 0. Well, if we move right 3 units, we're going to be over here, right, at 3, 0. So let's go ahead and plot that. And look at that here. So over here at our point, 3, 0 will be our starting point. Now we know that 1, negative 1, if we go right 3 units, so if we would add 3 to that x-coordinate, that'd put us over here at what? That'd put us over here at 4, negative 1. So I'll go ahead and plot 4, negative 1 as we go right 3 units. 4, negative 1 be on the graph. All right. Let's put that on here. So we're over here with this one. So there's 4, negative 1. So again, going right 3 units. And where's 4, negative 2 going to move to? It's going to move over here to 7, negative 2. So 7, negative 2 be on there. So we want to graph it in, right? We pushed our graph horizontally to the right 3 units. So there's the horizontal shift. So here's the graph right now, y equal to negative square root of x minus 3. And now we're looking at our last change, which is the plus 2. So the plus 2, that's going to cause a vertical shift up 2 units. So anytime we add or subtract a constant to our function, it moves it vertically. Plus we go up, minus we go down. So we're going to shift up 2 units. So every ordered pair, right, xy, right, we'll be looking at a point of x, y plus 2. Add 2 to each y coordinate. So let's go ahead and do that on our graph here in blue. So example 3, 0, as we go up 2 units, we'll be up here at 3, 2. And we know, for example, 4, negative 1, if we go up 2 units, we'll be right here at 4, 1. So we'll pass through 4, 1. 7, negative 2, as we go up 2 units, we'll be up here at 7, 0. And now I can go ahead and graph in my final graph. So I'll put it in here in a solid picture. We'll put 7, 0 over here. But you see your graph now. So beginning over here at 3, negative 2. So now I've got my graph of f of x. Here's negative square root of x minus 3 plus 2. So you can see those transformations, right, take place. So we had 3 transformations. Right here, our 3 characteristics of this graph. We had a horizontal shift to the right and then up after the reflection took place. And you can always step it off too. If you're not sure about your characteristics, you can go to your calculator and look at it. So if you want, pull up your TI. That's what I mean by checking your work graphically. All right, we know our calculator, not going to miss it. Let's go to our TI. Let's put in the square root model. Let's put in that graph starting at 0, 0, passing through 1, 1, passing through 4, 2. You can see your different points. I used a few of these, right? Just a few easy points to plot. Let's show the transformation. So you say, what did that negative do? So putting a negative out in front of the square root, we said turned it and flipped it upside down across the x-axis. Well, now you see that, right? It's a mirror image across the x-axis. Every ordered pair xy, you see x negative y. You see that reflection. So 1, 1 is now 1, negative 1, right? 4, 2 is now 4, negative 2. And then you say, well, what did the transformation? Let's go in here inside this x and let's put in the minus 3 because we said that was going to shift it to the right 3 units. So let's see that. You see it now going right 3 units. So now you're starting over here at the point 3, 0, right? You're looking at the point, right? 1, -1 is now at 4, -1, right? And you're looking at that point that was 4, -2 is over at 7, -2. You can go to your table and check it. And then I'm going to put in my final change, which we said was moving it up 2 with the +2, and there it is. So you can see your final graph, and you can go to your table. It'll tell you your graph in black is the final result. There's that point 3, 2 that we plotted. There's 4, 1. There's 7, 0. Those 3 points that we sketched by hand. So again, using transformations, right, to look at our graphs. And then you can analyze it. So from there, we can talk about the domain. We can talk about the range. All right, so if I were to ask you, what's the domain of this function, we could go ahead and answer that. Where does this graph take place along the x-axis? Well, domain, the x values, would be what? From 3 all the way to infinity. So bracket 3 to infinity would be the domain. If I asked you for the range, where does the graph take place in the y-axis? Well, you'd say all y values less than or equal to 2. So -infinity to 2 with a bracket, right? And starting point's 3, 2. So there's your range, your y values. So again, you can analyze easily once you have the graph. So that's a review of your transformations. I want you to be able to explain those, be able to give me those characteristics. That's the main thing, right, to take away from this is how do you get the graph. You can explain the transformations. You can easily sketch it, right? Let's take it and turn around and go the other way. Look at our last problem, 19. Let's do another problem here with transformations. Is that this time they give us the transformations, and they ask us to produce the equation. So here it says, talk about the shape of your absolute value function, which is your V-shaped graph through the origin. It says the shape of the absolute value of x function reflected across the x-axis. All right, well, reflecting across the x-axis, right, that's going to be multiplying by what? A negative. So reflecting across the x-axis would be y equal to negative absolute value of x. Now again, if we want to reflect the y-axis, the negative will go inside and directly affect x. So we should review that also. We could have that characteristic come up. Y-axis, you need to multiply your domain variable by negative, not your function. So you would go back, for example, in problem 18, you want to see reflection of the y-axis, you go inside and multiply x by negative. Square root of negative x, the reflection with the y-axis. So there's your reflection with respect to the x-axis, right, the negative. And now as we go through our second characteristic, we then want to shift 3 units to the left. So let's go ahead and write that down. We'll go ahead and apply it. So shift left 3. So that would imply y equal to negative absolute value. Got to go inside, directly affect x, and we're going to subtract a -3. All right, which implies what? Y is equal to the negative of absolute value of x plus 3. So you're subtracting a -3 if you want to go left 3 units. So again, multiplying by the negative causes a reflection. Subtracting a -3 causes the shift of left 3 units. So again, I'll make note of these characteristics. And then our last, it says finally, the graph needs to be shifted down 5 units. All right, so let's go ahead and apply that transformation. So down 5 units means we need to subtract a 5 from the function. So a -5, down 5, -5. So here's our new function. So here's f of x. So f of x equal to negative absolute value of x plus 3 minus 5. So we transformed it. So we walked it off going through those operations. So again, application using reflection and horizontal and vertical shifts. So I hope that helps you with transformations. And that finishes up our review. So these are all good problems, good test questions that will help you prepare for your unit test for Unit 2 here.